We've been working on rational functions for the last couple days, solving rational functions, simplifying rational expressions, things like that. So now I'd like to talk about applying rational functions. A lot of times when we say the word applying, we mean like real world problems, right? Word problems. Okay, so that's where we are today. In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. A tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? Would you mind it? Thank you. So, now, like crazy people, when they first see this problem, they're like, okay, 4 years and 3 years, 7 years! And then everyone just rolls their eyes and shakes their head, right? Because you know what's going on, right? Here's a mountain. I'll draw a beautiful mountain, right? One starts here and goes this way, and one starts here and goes this way. And hopefully they've done their math right so they can actually meet like in the middle somewhere, right? Somewhere near the middle. But if it takes 4 years, but this one by itself, and 3 years, this one by itself, is it going to take 7 years to go all the way through the mountain? No, not at all, right? It's going to take less than both of them, isn't it? Okay? So what we have to do is we have to figure out how this problem is being set up. Okay? So we're talking about rational functions, right? So is it logical that this is going to start out looking like a fraction? Yes, okay? So what we need to do is, first of all, is we need to define our variable. Now, when I say define a variable, I don't mean like this. X, that's a variable. Because then the whole rolling of eyes things happen, because we all know X is a variable, right? What I mean by when I say define a variable is we have to decide what variable we're using, which in this case, we'll say X, and then what does it mean? What's it going to stand for? Well, what is the question asking us to find? How long it's going to take for the two machines to work together. Okay? So let's say X is going to be the number of years together. Does that make sense? So we have one job, correct? Our one job is to tunnel all the way through the mountain. So is it logical that one job would take one machine 3 years? And one job, if the other one is working, it's one job being in 4 years, right? But we're trying to figure out how long it takes them together. So what should that equal? That one job over X. Perfect. Well, guys, this looks really similar to the problems we do in the last couple days, correct? So, what would be our common denominator? 12x. That's exactly right. Now, are we going to get a common denominator, or are we going to be denominator assassins? Denominator assassins. I want to multiply each term by 12x. What happens in this first fraction? Does anything simplify in the first fraction? The 3 and the 12, yeah. What happens here? Do they just both cross out? 12 over 3 equals 4, right? So what am I left with here in the first fraction? 4x. What happens in the second fraction? Same thing, but it's 12 over 4, and that equals 3, right? What's that? Plus 3x. What happens in the last fraction? Yeah, x's simplify to 1, don't they? What's that equal? 12. Wow, that looks like a really easy equation to solve. 4x plus 3x equals 12. Is that right? How do I solve that? Oh, 4x plus 3x equals 7x? Okay. 7x equals 12. How do I solve for x? Divide by 7. X equals what? Now, I agree with you that 12 over 7 is the right answer. I'm not arguing that at all. In the context of this problem, does 12 over 7 make any sense? No. What do I need? I need either 1 5/7 or 1.7. Is that correct? Now, I just saw some frustration happen. Please remember, if you put in 12 divided by 7, enter, it's going to tell you 12 over 7. Right? Remember, you got to do control enter for the approximate value. But still, does this make any sense? 1.7. 1.7 what? Years. So, in a complete sentence, tell me what this answer means. Start with this. It will take 1.7 years for both the machines working together. That's exactly right. Okay? Questions? We good? Look at number 2. Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. First, we got to define our variable. What variable would you like to use in this problem? X. So if we're using x, what does x mean in this problem? Speed of whom? Well, we could choose it to be the speed of Tobias, but we also know Tobias is driving 20 kilometers more than the speed Alicia's driving. So would it make sense for us to call x the speed of Alicia? If we know x is the speed of Alicia, how fast is the speed of Tobias? 20? 20 more. So how do we notate that? Perfect. X plus 20. And we're going to write that that's the speed of Tobias. Notice in the first question, it was only asking us for one answer, wasn't it? When will the tunnel be finished? If they're working together, when will the tunnel be finished? That's only one answer. This question, even though it's not a question, but we'll argue about that later, find the speed at which Tobias is driving and the speed at which Alicia's driving. So I've got to have two different things to find here, don't I? Alicia's speed and Tobias's speed. All right. Have you guys ever seen this formula before? D equals RT. Have you ever seen that before? Yes? What does it stand for? Do you remember? Distance equals rate times time. Okay? Now, I mean, I'm giving it to you this time, but would you have been able to come up with this formula on your own? This needs to be a formula that you can come up with. Okay? This is a fairly popular formula. I'm not saying formulas are ranked in order of popularity, but I'm saying it's used quite often, both in algebra and physics, okay, like science, okay? So this is a formula you need to know. Distance equals rate times time, okay? So what do we know? Well, we know Alicia's speed is x, and we know Tobias's speed is x plus 20. But we also know this. Let's see, where is it? Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. So what's the same? The time. Well, it would be nice if this formula was solved for time, right? Is that something we can do? Oh, how would I do that? Very good. I divide both sides by r, and I would get d over r equals t. Well, do you agree with this, that the time of Tobias equals the time of Alicia? Is that true or not? If they drive in the same amount of time, that's absolutely true. But I know then that the distance over the rate should equal Tobias's time, and the distance over the rate should equal Alicia's time. So all I need to figure out is Tobias's distance and rate, and Alicia's distance and rate. But guess what? Yeah, we already know those things, don't we? Okay? So what is Tobias's distance? 300. What is Tobias's rate? Or speed, right? Yeah, we already defined that, didn't we? X plus 20. And how should that relate to Alicia's stuff? Yeah, it should be equal because we said it was the same amount of time, right? So I need Alicia's distance, 200, over Alicia's rate, x. Have we done any problems like this lately? Yeah, absolutely. How do I solve this? I could absolutely cross multiply. When I cross multiply, I get 300x equals 200 times x plus 20. Does anyone know what 200 times x is? Oh, 200x. Good job. 300x equals 200x plus, 4,000. How do I solve for x? Subtract 200x from both sides. That gives me 100x equals 4,000. Good. Divide by 100. X equals 40. What's that mean? So it's really kilometers per hour? And that's Alicia's speed, right? So now we're done because we've answered the question? Why not? Yeah, we were asked two questions, weren't we? We were asked Alicia's speed and Tobias's speed. What is Tobias's speed? How do you know that? Because it's x plus 20. And if x is 40, then 40 plus 20 is 60. 60 kilometers per hour is Tobias's speed. Questions? Chef Craig can decorate a dozen cupcakes in half the time of Chef Charlotte. Together they can decorate a dozen cupcakes in 8 minutes. How long would it take each chef to decorate a dozen cupcakes alone? So this is a lot like problem number 1, isn't it? The two machines working together, trying to figure out their total time. The difference is, it's two chefs working together. We know their total time. We want to know their individual time. So yeah, it's going to look a lot like this problem up here, right? So first we need to define our variable. What variable would you like to use? X. And what's X going to stand for in this problem? First of all, how many things am I going to have to find in this problem? two, right? I'm finding two things. One of them is Chef Craig's time, and one of them is Chef Charlotte's time. So which one do you want to stand for X? Okay, so let's think about this. If we let X be Chef Charlotte, how fast can Chef Craig decorate? In half the time, which means if Chef Charlotte is X, Chef Craig would have to be half X. What if we let Chef Craig be X? How long would it take Chef Charlotte? 2X. You want to work with fractions or not? Not if we can help it, right? So let's let X be Chef Craig's time. So what did you tell me would be Chef Charlotte's time if I let X be Chef Craig's time? 2X. So now we need to set up our equation. What do you think our equation is going to look like? So we've got parts and then the whole, right? So like up here we had the parts separately and then we had the whole together. So one job takes Chef Craig how long? X. And Chef Charlotte how long? So 1 over 2X. But how long together? One job, 8 minutes. So how do you think we're going to do this? Yeah, you're way too excited about being a denominator assassin. It's okay. It's okay, though. As long as it's only denominators that you're assassinating. Okay? What is our common denominator here? Okay, so think about this for a second. What are the factors of X? Just X and 1, right? So I know that has to be part of my denominator. What are the factors of 2 and X? I've already got an X. Do I need a 2? Yeah. But then I also have an 8. Is 2 a factor of 8? So could I use 8 as part of my denominator? Yeah, 8X. So if I multiply every term by 8X, that should be enough to eliminate all of the denominators. What happens with the first fraction? X's eliminate, and we're left with 8. What happens in the second fraction? X's eliminate, and the 8 and the 2, right? And I'm left with 4. So, plus 4. What about equals what? Wait, this is maybe the easiest problem we've done all year. 8 plus 4 equals X. Excellent, you're right. 8 plus 4 is 12. So now we go on. Go on to the next problem. Are you ready to go on to the next problem? No, why not? We got X. We were asked two things, weren't we? Guys. Shh. We found that X equals 12. X equals 12 what? So Chef Craig takes 12 minutes, right? What else were we supposed to figure out? Chef Charlotte? How long does she take? Why? Because it's 2 times Chef Craig's time, right? Chef Craig's time is 12 minutes, so Chef Charlotte's going to take 24 minutes. There has to be some sort of explanation that you know what you solved for. This Up here, I wrote x equals 40 kilometers, which is Alicia's speed. And then x plus 20 equals 60 kilometers, which is Tobias's speed. I could have easily written that as a sentence, right? Well, in fact, this one I did write as a sentence. I can't just write x equals 12, 2x equals 24. That is not an answer to the question. You have to answer the question. If it takes you a sentence to write, or in this case 2 sentences, write one. If you can write something like this to make me think that you know what you're talking about, that's fine too. If I had a preference, I think I would probably prefer a sentence. Okay? Questions? Now are we ready to go on to 4? Oh, okay. One pipe can fill a tank in 6 hours, while another pipe can empty it in 2 hours. If both pipes are open at once, how long will it take to empty the full tank? What's it asking us to find? The time to empty the full tank. So guess what variable we're going to use? What? P, all right? P, why did I choose P? Because she said. T works as well. What's T going to stand for? The time to empty the full tank. Time to empty the full tank. Now, am I going to expect to see this every time? Am I going to expect to see you define a variable every time? Yes. It's going to be part of the grade. You don't do that, you're going to get points off. It's important that you know what the variable stands for. Okay? So now that we have defined our variable, now we need to set up an equation, don't we? How is this equation going to be different from like Chef Charlotte and Chef Craig? Well, yeah, Chef Charlotte and Chef Craig are working together, aren't they? Are filling a tank and emptying a tank working together? How are they working? They're working against each other. Which one's faster? Filling the tank or emptying the tank? How do you know? Yeah, it only takes 2 hours to empty the tank, and it takes 6 hours to fill the tank. So, if we say 1/2, which is the time to empty the tank, partly empty the tank, right? Another pipe can empty it in 2 hours. And we subtract 1/6, which is how long it takes one pipe to fill it. Why are we subtracting? Because they're not working together. They're working against each other. Okay? What should that equal? 1/x. Because that's what we're trying to figure out. How long does it take to empty the full tank? Oh, thank you very much. I'm so sorry. It is a T. Got so carried away. So what is our common denominator? 6T? Could I use 12T? I could, but that's not my least common denominator, is it? Okay? So if I use 6T, and 6T. What happens in the first fraction? Do I eliminate my denominator? Yeah, and I have 3 left over, so I have 3T. What happens in the second one? 6 is eliminated. What's left over? T, so minus T. What happens in the last part? T's are eliminated, aren't they? T divided by T is 1, so I am left with 6. Does anybody know what 3T minus T equals? Oh, 2T. Divided by 2? T equals what? 3. What's the answer to the question? It will take 3 hours to empty the full tank. So you're telling me you can't just write the equation and get the answer and go on to the next problem? You have to define a variable every time, and you have to answer the question every time? Yeah, absolutely. This should probably be a capital I. Sorry. Any questions? You have 4 problems to do on the back of the worksheet for homework, and you have the rest of the period to work on them.